Alright, so this video is about multiplying polynomials. And basically what this says is 3 times 6x times 2xy times x squared y to the fifth. And the reason why I know it's times is there's no time sign in the middle. Like you might remember time signs being these x's. A lot of times in Algebra 1 we don't write the x's. The reason why is this little x looks like that x. So it's very confusing whether it's an x or it's a time sign. So for that reason, instead of using the x's, we usually use a dot or nothing at all in between the numbers. So if I write nothing at all between these two parentheses, like this parenthesis and that parenthesis has nothing between them, that means it's been multiplied. Or we might be nice and give you a dot. So I could put a dot between each one of these to imply it's been multiplied. But if you don't put a dot, just have nothing between them means not being added and it's not being subtracted, it's being multiplied. So this says 3 times 6x times 2xy times x squared y to the fifth. Now, because 6x means 6 times x, how do I know? There's nothing between the 6 and the x. Notice there's no plus sign or subtraction sign between the 6 and the x. That means there's an understood little dot here too as well. And for that matter, there's nothing between the 2 and the x or the x and the y. So for that matter, there's a dot here and there's a dot there, meaning all of those are being multiplied together. And going further, there's nothing between the x squared and the y. So since there's no plus or minus sign between them, that means there's a dot for multiplication happening here too. So one thing I can do is I can rewrite this without all the parentheses as just 3 times 6 times x times 2 times x times y times x squared times y to the fifth power. So from there, I'm looking for the numbers I can multiply together, like 3 times 6 times 2. I'm looking for the variables I can multiply together, like x times x times x to the second power, or y and y to the fifth power. So I'm going to multiply all those together. I can group together these numbers first. 3 times 6 times 2. I can group those together. And I can group together the x's. X times x to the second power. And I can group together the y's. So y times y to the fifth power. So if that's true, then 3 times 6 is 18. 18 times 2 is 36. And then x times x to the second. So that's x to the fourth. The reason why is this x has a power of 1, and that x has a power of 1. So 1 plus 1 plus 2 is 4. So there's no exponent on it, has a power of 1. So for that matter, 3 has a power of 1, the 6 has a power of 1, and so forth. But anyway, so this is x to the fourth. And the last one is y to the first times y to the fifth is y to the sixth. So the product of all of this, product means to multiply. So the product of all of this is more simply written as 36 x to the fourth y to the sixth power. Alright, so that's the first note on multiplying polynomials. Pause the video, copy that as a note. I got another example for you. Alright, so just so you know, product in math means multiplication. Product means multiplication or to multiply, either way you think about it. Product means multiplication or to multiply. Alright, I'm erasing this. Alright, it says multiply 5 times all of these numbers in the parentheses. So we'll multiply 5 to all the numbers that is within the parentheses, or find the product of all those numbers. So I'm going to take 5, and this we're going to do this thing called distribute. Distribute means to multiply to each number that's separated by addition signs or subtraction signs in the parentheses. So I'm going to multiply to 5, the 5 times the first term. First term is 7x to the fourth. And then the plus sign comes up, so multiply 5 to the next term. Next term is 30x to the third. Multiply 5 to the next term, which is 21x squared. then 5 to the next term, which is 6x, and 5 to the last term, which is negative 9. So we're giving each term a multiplication of 5. So this becomes 35 x to the fourth plus 150 x to the third plus 105 x to the second plus 30 x subtract 45. So I've distributed or multiplied 5 to each term that is within the parentheses that's been connected to 5. So that's how we distribute. And that's how we can multiply 5 to each one of those terms. I'll copy the answer and pause the video. New example. Alright, new example says to multiply 2x into all of these. Right? And we just learned a minute ago the word distribute. And this is one of those examples. Distribute. Alright, so this is one of those examples where we could distribute. The reason why is these terms inside parentheses here are not being multiplied together. They're being added together. Or they might be subtracted, but this has been added too. So this is being added and subtracted together. They're separate terms. The last example, they're all been multiplied. So we can connect them that way. But these have been added. So we distribute 2x to the first term, distribute 2x times the second term, and distribute 2x times the next term. So when we do this, this becomes, basically, you're going to multiply the numbers and the variables. So you're essentially thinking about this as 2x times 3x to the second power. So if you multiply that, you can multiply the numbers together, 2 times 3, and then you can multiply x times x to the second power. So 2 times 3 would be 6. X times x to the second power. So that's an exponent here of 1, and that's times. So that gives you x to the third power. So when I multiply the first term, the first number should be 6x to the third power. And then the second one is going to be 2x times 5x. Well, you might can kind of see what it's going to be. 2 times the 5 is 10. X times the x is x to the second. And then 2x times the 11. Well, this 11 doesn't have an x. So you only multiply the 2 and the 11. So it becomes 22, positive 22. And the x stays there with it. So it becomes 22x. So this product is 6x to the third plus 10x to the second plus 22x. Alright, we'll give you a new one like that. So pause this video, copy it as a note. I'm about to erase your screen. Alright, so I got a new example. And this example needs directions. Directions should be multiply. So we're going to multiply all this together. So in the first set of parentheses, I have 5x times 2x plus 1. So of course this is distributing, right? So you're going to distribute, change the color to red. Distribute 5x times the first term and 5x times the next term. Notice this is where the parentheses stop. So because this is where the parentheses stop, that's where I stop distributing the 5x. I should not distribute 5x to the 6x squared or the 3 because they are not in parentheses. That's multiplied to the 5. So this becomes 5x times 2x is 10x to the second. And then 5x times the 1 becomes 5x. And then these are not being multiplied and nothing special happening. They're just being added together. And they're unlike terms, so you can't really add them. So you can only call them 6x to the second plus 3. And if you notice any like terms, you should add them. And I see some like terms. 10x to the second and 6x to the second can combine to be 16x to the second. Notice how when we added them, we did not change the exponents, but when you multiply them, you do. So 5x plus 3 cannot be combined. So they're not like terms. So I'm going to give this 3 something else. So it didn't look like they're like, so it doesn't look like they're like terms. So 5x comes down and the 3 comes down. So they can only be added in that way. So my final answer is this: 16x to the second plus 5x plus 3. Another way of saying x to the second is x squared. All right, I got another example. So pause the video and copy that as a note. Okay, so in this example, we're multiplying two polynomials. One is x plus 2, and the other is x subtract 3. All right, because we're multiplying two polynomials, we multiply differently. In this case, we use for. First, outer, inner, last. What I mean by that is this. I multiply the two first terms, x and x. Then multiply the outer terms, x and negative 3. X times x gives you x to the second power, and x times negative 3 gives you negative 3x. And then I multiply the two inner terms, the inner and last term. So multiply 2 times x and 2 times negative 3. 2 times x is positive 2x. 2 times negative 3 is negative 6. I usually line them up this way because if everything, so a lot of times it lines up this way pretty easily, where the 3x and the 2x are like terms. So when I combine those, x squared comes down because it has nothing to add to. It has no like terms. Negative 3x plus 2x is a negative 1x. Subtract 6 has no like terms. So that product is x to the second, subtract 1x, subtract 6. And that's called for. First, outer, inner, last. We'll talk more about that in class though. Alright, final example is this. It says find the area of this rectangle. So this is my rectangle here. To find the area of any rectangle is length times width. The length of this rectangle is here. Call that my length. My width is here. But truthfully, it doesn't matter which one you call length and width. Since the length of the rectangle is, since the area of the rectangle is length times width, it should be x plus 6 times 2x subtract 1. In this example, we can use 4. So it's going to wind up being the first terms multiplied together. So x times 2x is 2x to the second. The second term multiplied together. So x times negative 1 is negative 1x. The middle terms, 6 times 2x is 12x. And 6 times negative 1 is negative 6x. Negative 6. So when you combine your like terms, you get 2x to the second, subtract, or plus 11x, subtract 6. And that's how we can use for on multiplying polynomials to find the area of that rectangle. Alright, so that's all I have. I'll write down this note, but that's all I have. Good luck.